Hello everyone, I am Animesh and welcome to my YouTube channel. In this video, I'm going to show you how we can calculate the coefficient of correlation. The calculations that I'm going to show you is both one step-by-step manual calculation and then how we can do it programmatically using Python. So before we begin, I would ask you guys, if you have not subscribed to my channel, please do subscribe to my channel so that you do not miss on anything. So let's begin. So first of all, when we want to calculate the coefficient between two variables, that is, one is x and the other is y, we see that in x there are numbers like 1, 2 and 3 and so forth, and y we have 9, 10, 11 and so forth. So what we are going to do, first thing is we are going to calculate the mean individually for each variable. That is, first we are going to calculate mean of x by summing up all the values and then dividing it by the total number of values, that is 6, and we get the mean as 3.5. And similarly we are going to calculate the mean for y and we get 11.5. Now the second step, we are going to calculate the deviation scores of x and y. Deviation scores are nothing but we are just subtracting each value of each variable with its mean one by one. So we have mean 3.5 and we get value of x, the first value is 1. So we subtract 1 by 3.5, we minus 2.5. Similarly, we subtract 2 with 3.5, I get minus 1.5, and so on and so forth. I do the deviation scores for all the elements in x, and similarly I do it for y as well. I subtract each value of y with its mean, that is 11.5, and I get all the values. So one way to do the checking whether you are doing it right way or not, you just sum all the values and you get 0. So if you are not getting 0, that means there is some error in calculation. Now moving forward to the third step, after finding the deviation score, what we are going to do is we are going to square each deviation score for each variable. So we calculated the deviation score minus 2.5, minus 1.5. Now we are going to just square them up. So we get this value, minus 2.5 square is 6.25, minus 1.5 square is 2.25. So this way I'm going to just do it for x and y both. I'm just squaring each individual deviation score. Now moving on to the fourth step, after doing the squaring of the deviation scores, I'm just totaling it up. I'm just summing it up for each variable, that is x and y, and I get 17.5. It is nothing but the summation of the squared deviation scores that we just did. In statistics naming convention, we also name it as SSX for x variable and SSY for the y variable. And now moving on to the fifth step, now we are going to do the cross product. Cross product is nothing but it's just the multiplication of the corresponding deviation score that we first obtained in our second step. It is minus 2.5 into minus 2.5 in our case, so it will be 6.25. And similarly I'll do it with the second row elements, minus 1.5 into minus 1.5, I get 2.25, and similarly I'll do it for all rest of the rows and I get the total as 17.5. This is my SP. Now moving forward to the sixth and the final step, it states that if you want to calculate the Pearsons R, that is coefficient of correlation, then we need to divide the sum of cross product that we just calculated divided by square root of sum of squared scores of x into sum of squared scores of y, and then I get my correlation coefficient. These are the list down values, that sum of the cross products is 17.5, the sum of the squared deviation for x is 17.5, the sum of squared deviation for y is 17.5, and now I put them in this formula. I get 1 as my coefficient of correlation. So 1 strongly represents that it is highly correlated. This is something which is an ideal scenario that we have taken. Now we are going to see how we can do the calculation of correlation coefficient using Python. So I have my Jupyter Notebook console open over here, and here I am going to import two main libraries, which is pandas, and I'm abbreviating it as PD, and then I'm importing NumPy and I'm abbreviating it as NP. So if you have not installed these two libraries, first you need to install these two libraries. I'll show you one for example. If I want to install pandas in Jupyter Notebook, I will first type exclamation. I will type pip install pandas, and then I'm going to just execute this. In my scenario, I have already installed it, so I'm not going to execute this right now. So let's move to the next step. Now we'll see what are our x and y variables. So these can be my x and y variables. So I have a list of elements in x and the same list of elements in y. Now I just want to calculate the coefficient of correlation between these two variables. So first way I'm going to see using NumPy. So I'm going to use the coefficient correlation function of NumPy, which is nothing but npcorr coef, and inside the parentheses I will pass these two list of elements x and y, and then I'm going to index it with 0 and 1. Let's just not index it now. I'll just execute it. So let's just execute this. And now we see that I get a matrix with coefficient of correlation. So I see that minus 0.085 is my coefficient of correlation between these two variables. These 1 are nothing but the coefficient of correlation with themselves, like x and x. It will be obviously 1. So this is my coefficient of correlation. But now I want only the value of coefficient of correlation, so I'll just index it. Say I want to pick only this value, so I'll just index it with 0, that I want 0th row, and I want the first number column, that is the second column, but index value is the 1, and I execute it and I get the value. So now we saw that how we can do it using the NumPy. But now let's suppose I want to do it using pandas. So first in pandas we need to convert it into a data frame. So how we can do it? By using PD data frame, and inside that I'll pass the list of the list that we have for two variables, and then I'm going to take transpose of it. So let's just execute. Let's see how we get this data frame. So I get the 0th column as my x and the 1th column as my y variable. So simply now I would like to get the coefficient of correlation. So I'll use df.corr open close parenthesis, and this will give me simply the same matrix that we got from NumPy. I'll just execute it, and I got a data frame with exactly the same values with coefficient of correlation. Again, we can do the indexing just like we did for NumPy, and we get the value of coefficient of correlation. So this is how we saw how we can calculate the coefficient of correlation manually. Then we saw how we can do it programmatically using two libraries, NumPy and Panda. I hope you guys like this video. Please do subscribe to my channel. I'll see you in my other videos. Till then, bye bye.